So now we're going to use PredictMT2, the prediction function that takes in a midterm 1 score and says for the control group, here's what we would expect an average midterm 2 score to look like. We're going to use that as a prediction for what we would expect from a student if they weren't treated in any way. And then we're going to compare that prediction to how the students who received mentoring actually performed on midterm 2 and see if they beat their prediction or not. Okay, we're going to add a column called improvement, which is the actual midterm 2 score minus the predicted midterm 2 score. Then we're going to draw a histogram of how much people improved over the score that we expected them to get under the control condition. And we'll group by whether they were mentored or not. Here's the histogram. Let's just look at the blue histogram for a moment. It's centered on 0. It's pretty symmetric, a little bit higher here than it is there. These are about the same. These are, well, this one's a little bit higher than this. But it's kind of just a normal distribution between -20 and 20. And this distribution says some people did better than expected, some people did worse than expected, with most of the scores between 10 points worse and 10 points better than expected on midterm 2. And what does it mean than expected? Well, this is according to the prediction based on the graph of averages based on their midterm 1 score. So this is actual midterm 2 observations. This is midterm 1 observations transformed onto the midterm 2 scale using regression. But not linear regression, instead just using the graph of averages in order to make predictions about midterm 2 scores. So now we really have some notion of how much better they did on their midterm 2 than they would have based on their midterm 1 score. And the blue distribution for students who did not participate in mentoring is roughly normal. And what about the yellow histogram? So these are the students that did receive mentoring. Some of them did worse than expected. Some of them did better than expected. In fact, more of them did better than expected than worse than expected, which is why most of the area of this histogram is over here on the right. And let's look at this bar in particular. These are students who did 10 to 15 points better than expected. That's a bar of width 5 and height 2, so that's 10% of the students in this category of being mentored did 10 to 15 points better on midterm 2 than we would have expected based on their midterm 1 score, versus only 5% of the students who did not participate in mentoring. That's a quantification of the effect that we cared about in the first place, because we're comparing a control to a treatment, and we're measuring some reasonable way of quantifying improvement between midterm 1 and midterm 2. Here's another way to do it. We can ask, what proportion of the students got an improvement of at least 5? So we take all the values of all the improvements, figure out which ones are at least 5, count those up using sum, divide by the number of people in that category at all, whether it's mentored or not mentored. And then we're going to group the original table using this function as an aggregation, and we'll see that for that non-mentored group, about 22% improved by 5 or more, whereas in the mentored group, 29.6%, considerably larger proportion, improved by 5 or more points. So that's another quantification. This difference between 29.6% and only 21.9% shows that there's some association between being mentored and improving on midterm 2. Are we done, or is there one more thing we should check? Think about that, and we'll finish up in the next video.